Okay, so for this question, we have a slit of width A which is illuminated by white light. For what value of A will the first minimum for red light of wavelength 650 nanometers appear at theta equals 15 degrees? Okay, so this is pretty straightforward. We've been asked for the first minimum, so therefore we can use our equation A sine theta equals m lambda. Now in this case, m is going to equal 1. We already have our wavelength at 650 nanometers. We have our angle, which is 15 degrees. So let's just rearrange this to get A on its own. And now we sub in everything we know. And when we do that, we get approximately 2.5 by 10 to the minus 6 meters, which is roughly 2.5 micrometers. And that is the answer to part A. Part B. What is the wavelength, lambda prime, of the light whose first side diffraction maximum is at 15 degrees, thus coinciding with the first minimum for the red light? Okay, so if this equation here tells us or describes where the first minimum is going to be, the first maximum, remember, is roughly in between minima. Now it's not quite, but it is roughly going to be at an order number of m plus a half. Therefore, the first maximum can be described approximately by this equation here. A sine theta equals m plus a half lambda. Okay, so now what we want to do is we want to rearrange this to get lambda prime. This is our lambda prime, therefore. Now we sub in everything we know, keeping in mind that m, the order number, is going to equal 1. And when we do that, we get a value that is roughly 430 times 10 to the minus 9 meters. So that's roughly 430 nanometers. So that's the answer to part B. Part C, light of this wavelength is violet, far blue, near the short wavelength limit of the human range for visible light. From the two equations used, will the first side maximum for light of wavelength 430 nanometers always coincide with the first minimum for light of 650 nanometers, regardless of the slit width? Okay, so there's a couple of ways in which we can sort of think about this, I suppose. So if we use our equations, we can say, the minima occur when this is our equation. Maxima occur when this is our equation. Therefore, for the first minima and first maxima, we're going to get these equations. Okay, so if these are going to occur at the same location, therefore we can rearrange both of these equations to get sine theta on its own. Now sine theta, in this case, they should equal each other. They should be the same. Remember, these angles should be the same. That's what we're being asked. Therefore, lambda on A is going to equal 1.5 lambda prime on A. Therefore, your A's cancel. So long as lambda is roughly equal to 1.5 lambda prime, not exactly, but roughly equal to 1.5 lambda prime, therefore, you're going to have your first minimum for lambda always coinciding with the first maxima for lambda prime. So in this case, our answer is going to be yes. Part D, does the angle at which this overlap occurs, is that dependent upon the slit width? Okay, so we know that A sine theta equals lambda, which is also equal to 1.5 lambda prime. Now, the angle at which this occurs, this is not changing and this is not changing. Okay, so we know that yes, it does depend upon it. It's in the equation right here. So even though the fact that they occur at the same location is independent upon the slit width. The angle at which it occurs is dependent upon the slit width. And if we increase A here to make sure that lambda and 1.5 lambda prime don't change, that would mean sine theta has to go down. Therefore, as A increases, theta must decrease and vice versa. So therefore, this question, we would say, yes, if the slit width is relatively narrow, the angle will be relatively large, and conversely. So our answer in this case is A, and that's how we do this question.